Now we want to explain why the secret can actually be recovered, right, when we're doing Shamir. And so one of the ways to do this is by polynomial interpolation. And so what the theorem says is that if we have t distinct points, so if you have t distinct points, you have x1, y1, you have x2, y2, you have x3, y3. So if you have t distinct points, let's say in this case three points, then there is a unique polynomial of degree t minus 1 such that that polynomial passes through all the points. So like we said before, if you have 3 points, there's only one parabola that passes through those 3 points, right? And this is true in general. If you have 5 points, then there's only one polynomial of degree 4 that passes through all of them. And not only that, you have a closed form for that polynomial. This can be explicitly computed, and I think the easiest way is just to show an example. So let's look at the example that we had before in our first video of this lecture, where we were in Z5, and this was our polynomial, and then this is what we sent to each of the participants. So we sent 4 points, and we want to show that with any 3 of them, you can recover. So let's see how participants 1, 2, and 3, so these 3 equations, let's see how you can recover the secret from these 3 equations. So let's say we want to interpolate these 3 points. What we can do is we can go and apply this formula here. And what will happen is it's going to look in this way. And notice that this formula has the way it's designed is so that when you do f of 1, the x minus 1 cancels. Let me write it here. So for example, if you do f of 1, then x minus 1 here is a 0, so this cancels out. X minus 1 here is a 0, so this cancels out. And if you notice, when you do a 1 here, these cancel out and these cancel out, and so you get just f of 1, right? If you do f of 2, the same thing will happen. So if you do f of 2, then you're going to get 2 minus 2 here, so this will be 0, and this cancels out. You'll get 2 minus 2 here, and so this will cancel out. And here, when you replace by 2 and 2, this part will cancel out with what's under, this part will cancel out with what's under, and you'll get f of 2. And indeed, this is exactly how you design this polynomial, right? So this is how you do the polynomial interpolation. So this here is the way you can write, using this formula here, the polynomial that interpolates these 3 points. And remember that what we want is f of 0, which is the secret. So then if you just compute f of 0 here on this equation, you can just solve. So here you'll get, so you'll see like minus 2, minus 3, divided by 1 minus 2 is minus 1, times 1 minus 3 is minus 2, and so this cancels out with this, so this is a 3, so that's why you get a 3 f1, and so on. You just compute these, and it'll give you this. And so this tells you the equation for you to find the secret if participants 1, 2, and 3 get together. So the first participant just needs to multiply what he has by 3, the second one he has by 2, and the third one doesn't do anything, and if they add all of that together, they're able to retrieve the secret password. Now, if you want to do this for participant 1, let's say 3 and 4, you just do the same thing and you will compute how they do it. So for any configuration of 3 participants, you will be able to find what is the formula for them to decode, right? And so this is how you reconstruct the secret via Lagrange interpolation.